All right, so when I see a binomial, I'm immediately realizing that it's not a equals 1. I just jotted these notes off to the side so I can keep referring to them. In order to be a equals 1, we need 3 terms. That's only 2. So then I'm thinking it's GCF. I just have to check if it's GCF. It's not automatically GCF. There has to be something that they have in common. So if they don't have anything in common, then it's not GCF. But if it's a binomial, the first thing I would check for is a common factor. So we did this thing, we learned this thing in the calculator. That if you hit those buttons, this thing GCD comes up. And we can do a GCD of 54 and 45. I'm not going to put the negatives into the GCD. It doesn't work. You're going to get an error. So just keep that in mind. We can't use negatives when we do this. So math, arrow to the right, 9, 54, and was it 45, I think? So they have a 9 in common. So I know that I can divide out a 9. I just have to ask myself, is it going to be a 9 or a 9x? Would my GCF have an x in it for this one? No, why? Because 45 doesn't have an x. They both have to have an x for the GCF to be an x with it. So in this case, I'm just going to divide out the 9. So 54 divided by 9 is 6, and then we'll just keep the x on that. And negative 45 divided by 9 is negative 5. The most important part of a GCF problem is the GCF. You got to make sure the GCF's in your answer. So that 9 goes to the front. And this is my factored form. You okay with that one? All right, so again, this is another binomial. So I'm thinking it's GCF, but I've got to make sure that there's a common factor before I decide that. So again, I would math, arrow to the right, 9. And I'm checking for a GCD between 4 and 28. If you type that into your calculator, you get a 4, right? So they have a 4 in common. All right, so they have a 4 in common. Also, we talked about how when the first number is negative, the GCF is negative. So I'm going to put a negative on that 4. All right, that's only because the first number is negative. And if the first number is negative, the GCF is negative. Now, in terms of variables, I've got x to the 7 and x to the 6. Because they both have an x, the GCF will have an x. The GCF is going to have the lowest degree of the x's. So I can't put a 7 here, because then when I go to subtract 6 minus 7, I'll get a negative. All right, so I'm going to go with the lower one, which is 6. Okay, so because they both have a variable, I'll divide out a variable. And in this case, the lowest variable is 6. So from here, I'll do the division of the GCF. Negative 4 divided by negative 4 is 1. I'm not going to write the 1. X, 7 minus 6 is 1. I'm not going to write the 1. You can. You could write a 1 here and a 1 here if you want. Okay, you just don't need to. 1 is a placeholder, and since I have that x, I don't need that. 28 divided by negative 4 is negative 7. And 6 minus 6 is x to the 0, meaning there's no x's here. The x's cancel out. And then I can't forget that I have to write the GCF in front. That's the most important part. This is factored form of this one. When the first number is negative, the GCF is negative as well. Anybody have questions on that one? All right, for the third one, there's 4 terms, so again, it can't be a equals 1. So at this point, the only other method we know is GCF, so I would think, okay, maybe this one's a GCF. So I'm looking at my numbers, and I've got a 15 and a 10, and a 5 and a 1. So if I'm going to find the GCF between all of these things, if I'm using the calculator, which you don't have to, you've got to do it in steps. So I would do a GCD between 15 and 10. And that's 5 if you type that in your calculator. And then I would take that number, 5, and pair it with the third number, which is another 5. And that's 5. And then I would take that number and pair it with the last number, and that's 1. All right, so if you're looking at all of the coefficients, you end up with a GCF of 1. And we talked about how 1 is not a GCF. I'm not going to divide 1 from all of these. I'm going to end up right where I started. If you try to divide 5 from all of these, you're going to get a fraction here, 1/5. And that means that it's not a GCF. Okay, so 5 is not the GCF, 1 is, and 1's not a GCF. All right, so then I'm focusing in on the variables. I've got x to the 10, x to the 7, x to the 6, x to the 4th. Because they all have an x, then there is a GCF that's a variable. And I'm going to pick the lowest one. Okay, I can't divide out a 10 because when I do 6 minus 10, I'm going to get a negative. But I can do a 4 from all of them and avoid getting a negative. So I'm picking the lowest one. So what happens is the number just stays. And then I'm going to subtract the exponent. 10 minus 4 is 6. The number just stays. And I'm going to subtract the exponent. 7 minus 4 is 3. The number stays. 6 minus 4 is 2. What happens to the last term? Because there's no number that's going to stay. And when I subtract 4 minus 4, I get 0. It's 1. It's not 0. Right? It doesn't cancel out. A number divided by its exact self. If you type 5 divided by 5 in your calculator, you don't get 0. Right? It's 1. So this is like 1 divided by 1. I need that 1 still. So there's a 1 there. It's not a 0. That term does still exist. And then I need to put the x to the 4th in the front. I didn't check any of these in the calculator, but you could. y1 for standard form, which is the question. y2 for factored form, which is our answer. And our table should match. Right? So those were all GCF. I believe the next 3 are all a equals 1. All right, so we've got 3 terms here. The first term is x squared with no number in front. So here's how we're going to do it. We're going to do c, so like this is a, and when there's no number there, a is 1. This is b, b is 18. This is c, c is 56. The goal is to get 2 numbers to go in these spaces. Every a equals 1 problem looks like that in its answer. So I'm going to do 56 divided by x, and I'm going to look for numbers. And these numbers have to be next to each other. I'm leaving that out here. And then we're looking for numbers that add to 18. All right, so in my calculator, I'm going to do 56 divided by x. And I'm looking for numbers side by side that add to 18. I see 4 and 14 add to 18. So I'm going to use a plus 4 and a plus 14. So that's my factored form. This one's also a equals 1. A equals 1, b equals negative 11, c equals 28. So for this one in my y equals screen, I'm doing 28 divided by x, and I'm looking for numbers that add to, that negative belongs to the 11. So I need them to add to negative 11. All right, so in my y equals screen, 28 divided by x. The problem is, right now, all of these numbers side by side will add to a positive, so I need to go this way. That's negative 29, that's negative 16, that's negative 11. So I'm going to use a minus 4 and a minus 7. Can someone tell me what numbers they got for the next one? I feel like we've gone over enough. We don't need to do this one. What'd you get? I'm sorry, say it again.
320 or x plus 3 and then versus x minus 28.
X plus 3 and x minus what?
28.
28. All right. Seems good to me, right? Because negative 28 plus 3 is definitely negative 25. And negative 28 times 3 is definitely negative 84. So this one looks good. Same idea, same method. All right. Last one. this one's not A equals 1, because right now, A equals 4. So if A doesn't equal 1, then I'm assuming it's a GCF problem. So if I were to GCD a 4 and a 20, I would get 4. And then if I were to take that 4 and pair that with the 56, I would get another 4, which tells me that there's a GCF here of 4. I can divide all of these numbers by 4. What do we get when we divide the 4 out?
12x squared plus 5x minus 14.
Good. And then where does that 4 go? Does it disappear? To the front. All right, so we've got a GCF, we've got this on the outside. Now that we've done that though, we've got an A equals 1, a B equals 5, and a C equals negative 14. So we can factor this. We're looking for things that add to 5. Did anybody find something that multiplies to negative 14 and adds to 5? 7 and -2, but this 4 here needs to be part of the answer too. So the final answer has a GCF and an A equals 1, so you can factor twice here. How do we feel on that? All right, sub left a note, said you guys worked great, handed in the papers, which you totally did not need to do. But I just really needed to make sure you were okay with GCF and A equals 1 before we move on today. Today we're going to talk about what happens when there's no GCF and there's no A equals 1. So like when I see this problem, I can tell it's not A equals 1, and so my initial reaction would be, all right, if I can divide the 5 out, then I can force A to equal 1. But if I go to try to divide the 5 out here, I get decimals, right? So this problem is neither. That doesn't mean it can't be factored, it means it can't be factored with A equals 1 and GCF. This method is called A is greater than 1, because A is greater than 1, okay? The names are what they are, okay? A is greater than 1. It is a complicated method, okay? I highly recommend taking the notes while I'm doing that. There are a lot of steps to factoring A is greater than 1. Another name you're going to hear me call it is factor by grouping, and there's a reason that it's called grouping. We're going to have to group some stuff, pair some stuff off, but it's the A is greater than 1 method. We use this method for problems where A is greater than 1, but it also needs to be a trinomial. You'll see in the steps, we're going to use the letters A, B, and C, meaning we need the 3 numbers to make that happen. So in your toolkits, I'm going to factor the trinomial. It looks like this. Let me keep what page 7. All right, and there's lots of steps here. All right. The first thing you want to do is always check for the GCF, because maybe there is a GCF and then maybe I can do A equals 1. You are going to find that GCF to A equals 1 is a lot easier than what we're about to do. Okay, so what I mean by that is this problem is going to come off like it's an A is greater than 1 problem because A is 4. But when we checked for the GCF, it became A equals 1. A GCF to an A equals 1 is a lot simpler than what we're about to do. So you always want to check for that first. So I would check for that by dividing everything by the first term and seeing if I can get rid of the 5. But in this case, I can't. Right? When I try to divide everything by 5 to make it A equals 1, I get decimals. Okay, so that's what this first step means. Make sure there's not a GCF, because if there is, we might be able to make the problem easier. Okay, but if there's not, here's what we're going to do. We're going to multiply A by C, and we're going to record that number off to the side. We're not actually going to use that number in our answer, but we're going to use it in our work. So it's going to be like off to the side. So in this case, A times C is, A is 5, B is 11, can see is 2. So I'm going to do 5 times 2, and that's 10. And I'm just writing that number 10 off to the side. It's called the master multiplier. You don't actually use it in the problem, but we're going to use it in the work. Okay, so we've got that number off to the side. So now we're going to find numbers that multiply together to be the number from step 2, 10, but add together to be b. In the a equals 1 method, we do what multiplies to c and adds to b. But in the a is greater than 1 method, we have to take into account the a too. So we have to do a times c and then put that number in the calculator. So in this case, instead of putting 2 divided by x in the calculator, I'm going to put 5 times 2 divided by x in the calculator. So in the y equals stream, I'm going to do a 10 divided by x. All right, so this first step is different. It's not c divided by x, it's a times c divided by x. We're still going to look for numbers next to each other that add to b though. That part's the same. All right, so RB in this case was 11. So I want to look at numbers side by side that add to 11. Positive 1 and positive 10. We okay with that? Positive 1 and positive 10. Keep that in mind. So it says, find these numbers that multiply together. Find the numbers that multiply together to be the number in step 2, but add together to be b, 1 and 10. We will call these numbers d and e. So the sum of these two terms will replace your bx term. Okay, here's what this means, all right? When we rewrite this next step, we're going to keep the 5x squared, and we're going to keep the plus 2. But we're going to change the 11x. We're going to change the 11x to 1x and 10x. The two numbers we picked, right? We picked 1 and 10. 1x and 10x. Now, the order that you put them in doesn't matter, but it's going to make your life easier if you put them in a certain way, okay? So when I'm thinking of the number 5, would that pair better with a 1 or a 10? 10, right? When I think 5, I'm like, okay, well, 10 and 5 go easily together, right? They're multiples of each other. So I'm going to put the 10 next, and then the 1 after that. It doesn't matter. So I don't want you guys to think, like, if you don't pick the right order, you're going to get it wrong. You're not. Okay? The order doesn't matter. However, if you pick an order that's more logical, the next part will be easier. So when I see a 5, I think that's going to pair nicer with a 10. All right? So that's why I put that one next. You don't have to do that, but it will make the next step easier. All right? So it says, rewrite the original problem as ax squared. So that part stayed the same. Dx plus ex, that was our two new numbers. And then plus c stayed the same. So the first and last stayed the same. We're reworking the middle. Now what we're going to do is the factor by grouping part. Because now we have 4 terms, we can group them in sets of 2. So I'm going to group the first 2 numbers and the second 2 numbers by putting them in parentheses. I'm pairing them off. This is called grouping. We're grouping the first 2 terms and we're grouping the second 2 terms. What we're going to do is step 5, factor out the GCF between these 2, and then we're going to factor out the GCF between these 2. We're going to factor out GCFs separately. We're doing 2 GCF problems here. All right? So let's do the GCF between these 2 terms. Maybe you know what the GCF is. Maybe you don't. If you don't, you could do a math, arrow to the right 9. 5, 10. All right, so those first 2 terms have a 5 in common, so I can take a 5 out of both of them. I'm not looking to do the GCF between all 4, just the first 2. Now, should that 5 have an x or not have an x? It should have an x, right? This has an x and this has an x, so the lower of the 2 is a single x. We're doing GCF here. Told you this one's complicated, all right? So now, if I'm looking to do the GCF between the second 2, it's 1. And to do they both have an X? So in this case, the only GCF is 1, and I know I've said 1 is not a GCF, but just for the sake of formatting, I'm going to do this. It's not going to change anything, but now at least everything has the same format, all right? Sometimes those two numbers will have a GCF. This example, they just didn't, all right? But I'm putting a 1 there just to hold the place of the format. We okay so far? All right, now we're actually going to divide them out. So 5 divided by 5 is 1. You could write the 1, you don't have to, all right? X squared divided by x, remember we're subtracting this, so it's 2 minus 1, so it's x to the first. I'm not going to write the 1. This is like 1x to the first. Plus 10 divided by 5 is 2, and 1 minus 1 is 0, so I'm not going to write that, right? So I'm dividing, I just get x, I'm dividing, I get 2. And remember, the most important part of a GCF is the GCF. The 5x has to go to the front. I'm going to do the same thing, even though it's going to be a waste of my time by dividing by 1. I'm just going to do it again, all right? So 1x divided by 1 is x, and 2 divided by 1 is 2. Nothing changed here. And I'm just going to put that 1 in the front. Anybody notice anything? They both have a number on the outside. What about the numbers on the inside? They're the same. If you get to this point and your numbers inside are not the same, you picked the wrong GCF, or you picked the wrong two numbers. Remember when we picked 10 and 1? Maybe you picked 5 and 2. It's not going to work out with 5 and 2. It only works out if you pick the right numbers. But this should always match. So if you get to this step and it doesn't match, you did something wrong. All right? The final step is going to be to take this and this. And because they match, we're just going to write it once. We're basically taking out a GCF again. The GCF is x plus 2. Right? So I'm going to take those two things and I'm just going to bring them together as a single x plus 2. And then I'm going to take this and this and I'm going to put them together as one factor. 5x plus 1. What we're really doing is dividing out a GCF. When we divide, and you don't have to write the steps, I think it looks complicated when you write it. But here's what we're doing. We are taking out the GCF of x plus 2. And when you take out a GCF, the GCF goes to the front. And what goes in the parentheses is what's left. Well, this would cancel out, and I'd be left with a 5x. And this would cancel out, and I'd be left with a 1. So what we're doing is factoring out the GCF. That step, though, looks kind of complicated. So I just tend to not write that step. And just go right to, I'm taking that repeated factor and writing that once. And then I'm taking the GCFs and I'm putting them together. This is factored form. And it's complicated to get there. I get that. We're going to do 3 of these total together. So we just said, well, we're going to do 2 more. And then I'm going to have you try to see if you can use the steps to do something. All right? So let's try the next one. All right, 3x squared plus 4x minus 15. In an ideal world, I can force this to be a equals 1 by doing this and getting an a equals 1. But I can't do that here because that's going to give me 1.33333. Okay, so if that was a number divisible by 3, I'd rather do a equals 1 than all that stuff. But I can't. Okay, so there's no GCF that I can take out. So what I'm going to do is I'm going to find this thing called the master multiplier, and I'm going to do that by doing A times C. A is 3, B is 4, and C is negative 15. The negative matters. You got to keep the negative on that. So when I do A times C, I'm doing 3 times negative 15. So the number that's going into my calculator is negative 45, not negative 15. I don't have to worry about that with a equals 1 because if I multiply the first number by the last number, the 1 isn't going to change anything. But in this case, the first number is going to change that. So a equals 1, or a equals 3 times c equals negative 15 is negative 45. So in my y equals screen, it's negative 45 divided by x. All right, what I am looking for are numbers that add together to be the b term, which is 4. So I'm looking for numbers in my calculator side by side that add to 4. So far, I don't see it, because this is negative 12 and this is negative 4. This one's positive 4 though, 9 and negative 5, right? So 9 and negative 5 are my numbers. Are we okay with picking the numbers? Okay, so here's what we do with them. 9 and negative 5. I am going to keep the 3x squared, and I am going to keep the negative 15. But I'm going to change the 4x to a positive 9x and a negative 5x. Let's think about what pairing makes more sense. Should I pair the 3 with the 9 or the 5? Which one of those makes more sense to you? Hopefully the 9 does. Pairing the 15 with the 3 makes more sense to me, right? So I'm going to put it in a certain order. The order doesn't matter, but it makes the problem easier if you pair it in a certain way. So it was positive 9, and I have to put an x on that, and negative 5, and I have to put an x on that, because I still need it to be 4. I'm just breaking that 4 up. 9 and negative 5 is still 4. I'm just splitting it up into 2 numbers. And the reason that I'm splitting it up into 2 numbers is I want to group. And in order to group, I need an even number of numbers. So now I have 4. So now I can group. So I'm going to pair this, and I'm going to pair this. And I'm going to find their GCF. So you can find the GCF in your head, or you can use a math arrow to the right 9. The GCF between 3 and 9. What's a number I can divide by both 3 and 9? 3. And should this GCF have an x or not have an x? It should. X and x. So this should have an x. It's not going to be x to the second though, because this one doesn't have that. So it's just 3x. What's the GCF between 5 and 15? 5. Or you can math arrow to the right. 5, comma, 15. 5. Should this have an x or not have an x? Should not have an x. What should it have? A negative. When the first number's negative, the GCF is negative. So I'm going to put a negative 5 on that. If you miss the negative, it's not going to match. And hopefully that'll tell you you did something wrong. So now, 3 divided by 3 is 1. I'm not going to write the 1. X squared divided by x to the first, I'm subtracting, is x to the 1. I'm not going to write the 1. 9 divided by 3 is 3. X1 minus x1 is x0. I'm not going to write x0. Most important part of the GCF is the GCF. So I need to put that 3x in the front. Negative 5 divided by negative 5 is 1. I'm not going to put the 1. I'm just going to carry down the x. Negative 15 divided by negative 5 is positive 3. Most important part of a GCF is the GCF. Notice they match. I have this x plus 3. If you have an x plus 3 in one and an x minus 3 in the other, you did something wrong. Right? They have to match. If they don't match, the problem doesn't work. And the final step is to take the part that matches and just write it once. X plus 3. And take the part on the outside. Take your GCFs and put them together. Really what you're doing here is factoring out the common factor of x plus 3. But in terms of like the steps, I'm taking that repeated factor and then I'm taking the other one. Everybody okay with that one? All right, last one we're doing together. Is this C? I'm going to skip that one. We're going to go D, right? So, D. Those numbers look big. I can't divide out an 18 though. That's not going to work. Can I divide out anything though? Let's see. Math 1833. So math, arrow to the right 9 of 18 and 33. Well, that's 3. And 12. Take that. Compare it with the last number. There's a GCF here, right? A GCF of 3. So I'm going to divide out the GCF of 3. What that's going to do is make the number smaller. Unfortunately, it's not going to change into an A equals 1 problem. That would be ideal. But it is going to make the number smaller. And if you can make the number smaller, they'll be easier to work with. So I end up with a 6x squared minus 11x plus 4. So A doesn't equal 1. A equals 6. So A is still greater than 1, but it's smaller than 18. So I'm still going to do the same method we've been doing. I'm just going to do it with smaller numbers. So when I do A times C, I'll do this down here. Instead of doing 18 times 12 and having this really, really big number, I'm going to do 6 times 4. 24 is a lot nicer to work with. All right? And so I'm going to do 24 divided by x. And I'm going to look for numbers that add to negative 11. So let's see what we've got. 24 divided by x. I want negative 11, so I'm going to go up. That's negative 25. That's negative 14. That's negative 11. So I'm going to use negative 3 and negative 8. Keep those in mind. Negative 3 and negative 8. I'm going to take my 6x squared. I'm going to keep it the same. I'm going to take my 4. And I'm going to keep it the same, and I'm going to split this 11. I want to use negative 8 and negative 3. Which one should I put with the 6? Which one should I put with the 4? The negative 3 should go with the 6. And the negative 8 should go with the 4. Order doesn't matter, but it's going to make the problem easier. Pair them with numbers that make a little more sense, right? So now that I have those two numbers picked, I'm going to group, pair them off, find their common factor. So I want to find the common factor between 6 and 3. If you don't know how to do that, this calculator does it pretty quick for you. 6 and 3. Remember, you can't put the negatives in here. So it was 6 and 3 and 8 and 4. So the first pair of numbers I can divide out of 3. The second pair of numbers I can divide out of 4. Now let's think about the variables. For the first pair of numbers, should I put an x or should I not? I should. What about for the second pair of numbers? No. Am I missing anything in the second pair of numbers? A negative. When the first number is negative, the GCF is negative. All right? The first number is negative. It's negative 8. So the GCF is negative. All right. 6 divided by 3 is 2. 2 minus 1 is just a single x. What about negative 3x divided by negative 3x? 1. You got to put the 1. It doesn't disappear. X to the 0 would disappear. 3 divided by 3 is 1. So when you don't have anything, you've got to put the 1. And then the 3x goes to the front. Negative 8 divided by negative 4 is positive 2. We'll just keep the x. 4 divided by negative 4 is negative 1. And the negative 4 goes to the front. Alright, so my final step would be take the two x's, the 2x minus 1, that common factor, and put a 2x minus 1. And then take the GCX, take your 3x and your minus 4, and make that a factor. What am I missing? What do we do in the very beginning? We factored out a GCF, right? That 3 is part of the final answer. It doesn't disappear. So at the very end, that 3 comes back. This is factored for you. That one's really, really tough. All right, so I'm gonna have you try, let's just say 1. I think 1 should be fair. All right, so let's try go to page 28. Let's try number 1. Page 28, number 1. Try factoring this one on your own. Use the steps. So I'm going to give you time to sit with it, use your steps, use your notes, and then I'll go over it before we head out to bed. we just start with what number are you putting in your y equals screen? What number did you put there? Alright, so if you're not there, into your y equals screen, you're doing a times c. That's 4 times 3. So y equals 12 divided by x. You're keeping the first and last the same. This is what I'm looking to split up. What two numbers did you pick? 12 divided by x, you're looking at a bunch of numbers. Which two do I need to pick? -6, -2. Order doesn't matter, however, I like a 6 with a 3. So I'm going to put the -6 here and the -2 here. Anybody have questions on that part? All right, I'm going to give you a few more minutes. Just in case you didn't get there, I wanted to get you started. So you're at this point, you're going to group and factor out a GCF. So if you didn't get to here, take it from here. Do this and start dividing out your GCFs. If you already did it, that's okay, hang out. If you didn't do it, take it from there. Alright, what's the GCF between 4x squared and -2x? 2. And then should it have an x or not an x? Alright, so 2x. Alright, so 4 divided by 2 is 2, and when I subtract this, I get x to the first. -2x divided by +2x. Well, -2 divided by 2 is -1. Normally, I don't have to write that, but in this case, the x's cancel out, and so I need something there. So it's going to be a -1. All right. Normally, you don't have to write that at all, but when everything cancels out, you need it. So then the 2x goes in front. What's the GCF between -6x and +3? -3. -6 divided by -3, the double negative is a +2, and then the x just stays. +3 divided by -3, normally I just wouldn't write that, but because there's nothing there, I have to write something. That's -1. And the -3 goes to the front. Last step, I'm going to take these and just write them once. And I'm going to take these and I'm going to write them together. This is factored form. You could multiply this out and see if you ended up back where you started, or you could do a y1, y2 and see if you end up back where you started. You can check your work two different ways. It is complicated. Eventually your notes aren't going to be there. You're going to have to know the steps. But for now, you've got notes to use for the steps. So when you come in tomorrow, we'll do a ticket in and then we'll split. I think we're definitely gonna need to split. I think some of you are gonna have this and some of you are not, and that is totally fine, all right? So tomorrow, we're not learning anything new. We are just practicing with this A is greater than one method. You've got a math Excel. At this point, you can do 1 through 21 if you're keeping up with it. It's not due until the 7th, which is next week.